Good morning, students. Welcome to my next class. Actually, in the last class, in the previous class, we discussed about how to find out the percentage of any value. Now you are able to find out any percentage value, right? Suppose today we will discuss about the applications of percentage problem. Actually, how they will ask the questions based on the percentage. Actually, percentage problem. Without using any pen, now you are able to answer my question, like what is 20% of 160? What is 20% of 160? 160 means 160, right? 20% of 160. 10% is 16. Then what is 20%? 32. What is 99% of 300? What is 99% of 300? How you will think that I want to know? 99% is nothing but 100 minus 1%, right? 99% of 300, how you will calculate? 300 minus something, 300 minus 1%, right? What is 300 minus 1%? 297. 99% of 300 is 297. Now, we will move to a new topic, the effective percentage. Effective percentage. Suppose I am asking, suppose I love, let a shopkeeper increases 10% value of his goods. Suppose he increased the price of his goods by 10%. After that, again, he increases 10%. The question will be like, what will be the effective percentage of change? What will be the effective percentage of change on the goods, on the price of goods? In general, most of the people, most of the students directly say the answer. Like, first you increased 10%, then you again increased 10%. Then you may have a feel that the total change, total increment will be 10% plus 10% as 20%. But this is not correct. This is not effective percentage. Actually, how it works actually, in the first instance, let the value be 100. The initial price of a good, let it be 100. Why 100? It is based on the percentage problem. So we consider, we solve most of the problem based on the 100 value, right? Let the first initial value, initial price of the good, let it be 100. Then, after increasing 10%, what will be the value? 100 is your original value. Then you add 10% more. 10% of 100, you have to add it. Then what is 10% of 100? It is 10, nothing but 10. Then 100 plus 10 will get 110. In the first instance, after increasing 10% of that good, the later price will be 110, right? This is in the first case. The first instance, after increasing 10%, the value will be 110. Then check this second case. You are adding this 10% not to the initial value. Actually, you are adding this 10% to this value, 110. Now, you have to consider, you have to add 10% of this value, not 100. Right? Then you have to add in the second instance. What actually happening is, in the first instance, your price is 110. In the second case, you have to add 10% of 110. Not 100, it's 110. What is 10% of 110? 110 plus 10% of 11 means 10% of 110 means 11, right? So your final price will be 1 plus 11 110 plus 11 should be equal to 120. Right? So what is the increment? Actually, what is the effective percentage of rate? Initially, it is 100, right? If the initial value is 100, now what is the final value? 121. Okay? The final value is, initial value is 100, your final value is 121. What is the rate of increment? How much percentage it increased? 21 percentage. 100 to 121, which means 21 percentage increased. The initial, you got the answer as 10 plus 10 as 20 percentage, but actual percentage change is 21 percentage. More than that of 20 percentage. Okay. Based on this effective percentage, they may ask a problem like compound interest and simple interest, and also by giving the length and breadth of a particular rectangle, how much percentage it will increase in the area, total area, they may ask. Actually, we will discuss such a problem, right? First problem. Suppose a shopkeeper increases the price of his goods by 20%. Increases his price of goods 20%. 20%. And again increases by 20%. And again increases the price of goods by 20%. You have to calculate the net effect on the price of the goods. You have to calculate the net effect on the price of goods. Okay. Again, same. The conceptual method is, first you have to increase 20%. If the initial value is 100, 100 becomes 20% more, right? You have to add 20% more with 100. This is the initial value. The first stage, you have to add 100 plus this 20% of 100. Okay. The second stage, this value, first stage value plus 20% of this first value. Understand? So in the first case, he increases 20%. So 100 plus 20% of 100 means 120. 100 plus 20, 120. The next stage, 120 is your initial value. And he adding 20% more with this value. So 20% more with this value. What is 20% of 120? Here you have to calculate without using your pen. What is 20% of 120? 10% of 120 is 12.
24.
Yeah, 10% of 120 is 12. How? 1 point right to left. You will get 120. 10% of 120 as 12. Then what is 20%? Is double of 10%. Is 120 plus 44, right? 24. 20% of 120 is 24. Then the final answer will be 120 plus 24. So you will get 144 as your final value. If initial value is 100, the final value is 144. So how much increased? 44% increase. This is the effective percentage change. Effective percentage change is if he increase 10% in the first stage and again 20% in the first stage and again 20% in the second case. what will be the effective change? It will be not 40%, it will be 44%. For solving this type of problem, there is an equation how to find out the effective percentage of two values. Actually, this is the concept. You have to understand this. You have to understand this concept initially, then go by the new equation. For finding out the percentage, effective percentage value of 2%, how you will calculate it? Let A be the first percentage value and B be the second value, which means a shopkeeper increases his price of his goods 20% initially and again 20% in the second case, which means A becomes A becomes 20, B becomes 30. If the shopkeeper increases his price of his goods as 20 and 30%, A will be 20, B will be 30. Then you have to find out the effective percentage of these 2%, effective percentage of 20 and 30. Then how you will calculate if let A be the first percentage and B be the second one. Then the effective percentage will be A plus B plus AB by 100. The first problem, we consider A and B as 10%, right? The shopkeeper increased to 10%, 10% increased in the first, and again 10% in the second case. Then effective change, what is the effective change? You got 21% as your answer. Actually, we solve that problem based on the conceptual method, right? So here, how you will solve the same question based on an equation. A is 10, B is again 10, 10 plus 10 plus A into B, 10 into 10 by 100. This will be your effective change. 10 plus 10 is 20. 20 plus 100 by 100 is 1. 20 plus 1 means 21. 21% is your effective change. Then check the second case. This is the first one. Second, we consider 20% increases and again 20% increases, right? This is your second problem. How you will solve it? Here A has 20, B has 20. 20 plus 20 plus 20 into 20 by 100. 20 plus 20, 40. 40 plus 400 by 100, then 4. So you will get 44%. If A is 20 and B is 20%, actually the mode of change is increases, right? Actually 20% increases, which means it's a positive value. Again 20% increases, again B is a positive value. Suppose I am asking the new question. In the first instance, the shopkeeper increases 10% of his goods. Then he decreases 10%. First he increased to 10%, then after that he reduced by 10%. Then what will be the effective change? 10% increases and 10% reduces. You may have a feel that first instance 10% increased, then 10% reduced. The total effect may be like 0%. You may have a feel, but the effective percentage will be different. How you find out? The same equation you can apply. Here A is 10. What about B? B is reducing here. B is not 10. If I put B again as 10, I will get 10 plus 10 as 21% will be the answer. But here 10% reduces means I have to put a negative sign. Why? Actually he is reducing the actual amount of his good. So it is not 10, it is minus 10. Here A is 10, B is minus 10. So apply the equation A plus B. A is 10 plus B is minus 10. Then again plus A into B. A is 10, B is again not 10, it is minus 10. So if you multiply a positive and negative number, the result will be negative, right? That's why I put a negative sign by 100. A plus B plus AB by 100. Here B is minus 10. So 10 minus 10 minus. How this minus came? Actually A and B. If you multiply a positive and minus value, negative value, the result will be not positive, it will be minus. So 10 minus 10, 0. 0 minus 1, right? 0 minus 1, which means minus 1% change. Minus 1% change, which means 1% reduction. Actually, what does it mean actually? If the price of good in the initial case is 100, first of all he increased the price of his goods by 10%. After that he reduced by 10%. Then what will be the final value? What will be the final value? 1% reduces, which means 99. If the initial value is 100, the final value will be 99%. Actually it is a loss, right? The option, your option, they will say like 1% profit, 1% loss, or 1% increases, or 1% reduces. This type of option will be given. So that you have to very much aware about the sign. Otherwise, if you get the value as 1% plus 1%, you will check, you will go by a wrong answer. Based on this concept, we will solve the problem. One more method is there. Actually, I will explain a new method, a new tricky method actually. In most of your textbook, they will solve this type of problem by this method. A plus B plus AB by 100. Instead of using this equation, you can again solve the same problem in a new method, by a new method. As I will solve most of the problem in 2 or 3 methods. Whichever method is easy for you, you can select. If you understand the concept, percentage concept very thoroughly, then you can use the tricky method. Same problem. 10% in the first instance increases, and again 10% increases. You have to find out the effective percentage. In the first instance, you go by conventional method. In the second stage, you check equation method. A plus B, you are putting the values of A and B, right? Then you will get the effective percentage. The third method, actually, how are you solving it? Just check it. Let 100 be the initial value. Let 100 be the initial value. Here, the shopkeeper increases the price of his goods by 10%, right? So 100 becomes 110, right? 10% increases means 10% of 100 you have to add it. So 100 becomes 110, right? In the second case also, if I consider 100 as my initial value, if I consider 100 rupee as my initial value, the second case also, they are increasing 10%, right? The second case, what will be the increment 10? You have to add 10% of initial value. Why? Because I am considering 100 as my initial value. I am dividing this problem into 2. In the first case, if the value is 100, if the initial value is 100, I have increased 10% to the initial value 100. And again, in the second part of this problem, Again I am considering the initial value as 100 and again increases 10%. 10 becomes 11. Sorry, 100 becomes 110. 100 becomes 110. I am reducing this problem. If 100 becomes 110 means 10 becomes 11, right? Both are same. Again 100 becomes 110 means 10 becomes 11. Both are same actually. Right? Then what will be the effective change? I just multiply left and right. If I multiply left, 10 into 10 will get 100. Then again in the right side, 11 into 11, 121, square of 11. Which means, if the initial value is 100, the effective percentage after the second stage, by increasing 10% in the first stage and again in the 10% in the second stage, the effective percentage change will be 100 to 100, 121, which means effective percentage is 21 increases, right? 21% increases. Why? 100 now becomes 121. Actually, in the left side, I take the 100 always. Why? It is very easy to calculate based on 100. If the initial value is 100, what will be the percentage? This amount, 21% is increased. Right? In the second problem, what is the second problem? 20%, right? Suppose the problem is like 10% increases in the first case and 10% decreases in the second case. How you will solve the same problem in the third method by using the third method? 10 becomes, which means if the initial value is 100, in the first stage I am increasing 10%, which means 110, right? You understand the point? So 100 becomes 110 means 10 to 11, right? 10 change to 11. Here, if it is again 100, I am reducing by 10%. 10% of 100 actually, I am reducing it. Then if the initial value is 100, what will be the final value? I am actually reducing. Here I am increasing, right? 10% increases means I have to add 10 with the initial value. That's why 100 becomes 110. Now I am reducing 10%. If the value is 100, if the initial value is 100, what will be after reducing 10%? 90. How? I have to reduce this 10% from 100. 100 is your initial value, and you have to reduce 10% of 100, which means 100 minus 10. Why? I am reducing 10%. So 100, if the 100 is the initial value, after reducing you will get 90. Right? So 100 to 110 means 10 to 1, 10 to 11. Both are same. 100 to 90 means 10 to 9. Again same. Then I have to check the effective percentage. Left will be 100 again. 100 becomes multiply 99. So if the initial, it means, what does it mean? If the initial value is 100 for a particular commodity, the final value after increasing 10% and deducting 10%, the final value will be 99, which means 1% reduces, right? Actually 1% loss. In the first case, we solve the problem by conceptual method, second by equation, third one is by distributive method. Whichever is easy for you, you can use. Then I will give you one or two problems, right? You just got it. Length of a rectangle. Length of a rectangle length of a rectangle increases by 10%. Length of the rectangle increases by 10%, and breadth by 20%. This sign means increases, right? Length of the rectangle increases by 10% and breadth by 20%. Then what will be the effective percentage change in the area? What will be the effective percentage change in the area? Actually, it is same as the shopkeeper problem. In that case, he increases the price of his goods by a particular percentage. Here I am increasing the length and breadth. What will be the effective change in the area? If I solve this problem by using your equation, what is the equation? A plus B by AB by 100. This is the first method. Second one is, this is first method. Second one is tricky method, right? In the first case, A is 10, B is 20. You have to put the values of A and B in this equation. Like 10 plus 20 plus A into B means 10 into 20 by 100. 30 plus 2. 30 plus 2. Okay, 30. Okay, 32. Second method, the tricky method. How you will solve it? 20%, 10% increases, which means 10 becomes 11. In the second case, 20% increases. 10 becomes 12. So you just multiply. Then 100 becomes, left is 100. 130. 11 into 12, you will get 32. Here, what does it mean actually? What does it mean actually? If the initial value is 100, your final value will be 132, which means 32% increases, right? Here the value is plus, so the effective percentage is 30% increases. If the value is minus value, if you got the answer as minus 32, which means 32% reduces. Actually, it is a loss, right? You understand this problem? The next problem. A value is increased by 10%. After that, a value increased by 10%. After that, it reduced by 20%. First, 10% increases, and then 20% reduces. What will be the effective change to that number? 10% increases, then 20% decreases. What will be the final answer?
Minus 12%.
How? 10 becomes 110. 10 becomes 110 means 10% increases. 20% reduces. Then 10 becomes 8, right? 10 becomes 8. 11 into 8, 88. Which means if the initial value is 100, the final value is 88. In your options, remaining as 88% increases, 88% decreases, 12% increases, 12%. What will be your answer? Actually, 100 becomes 100 becomes 88 means the effective percentage rate is not 88. What is the effective percentage rate? 100 becomes 88 means 12% reduces, right? Here, the both options are given. 88% increases and 88% reduces. You don't go by this answer. The effective change is 100 becomes 88 means 12% change. How? It reduced. 100 reduced to 88 by 12%. That is the next one. Next problem. Price of a cinema ticket. Price of a cinema ticket is increased by 20%. Is increased by 20%. Then reduced by 25%. Reduced by 25%. What will be the effective price? What will be the effective price on that cinema ticket? Next one. If the radius of a circle, is reduced by 10%, if the radius of a circle reduced by 10%, what will be the effective percentage change in area? What will be effective percentage rate change in the area? Fourth problem. A number increased 20%. A number initially increased 20%, later reduced by 40%. A number increased 20% in the first case. After that, it reduced by 40%. Then what will be the effective percentage? What will be the effective percentage? You pause the video and try to solve the problem, right? What is the answer? First one? Okay, if you need more time to solve this type of problem, you have to first of all you have to pause the video. Then after that, we just compare with the actual answer. In the case of first one, 10% increases and 20% reduces. What will be the answer? You cross check with your answer. 10% increases and 20% reduces. What will be the effective? Minus 12%. Or 12% reduces. How you got the answer? 100 becomes 110. 10 becomes 11. 10 becomes 8. Right? Which means 100 becomes 88. Which means 12% reduces. 100 reduces to 88. 100 reduces to 88, which means 12% reduces. Then second one, 20% increases, 25% reduces. So 100 becomes 10 becomes 12, 10 becomes 7.5, right? What will your answer will be?
100 is 90. So minus 10%.
Yeah, 100 becomes 90%, which means 10% reduces, right? And radius is 10% reducing. What will be your area? You can say. What is the effective percentage rate of 10% after two consecutive reduction? What will be the effective change? 100.
Minus 10.
Yeah, 10% reduction means 10 becomes 9, right? Again, next stage, again you are reducing 10%. Again 10 becomes 9. 9 into 9, 81. Then 100 becomes 81 means 100 becomes 81 means
Minus
19% reduces. 20% and 40%. 20% increases means 10 to 12, 10 to 6. Here 10 to 12. Here 10 to 6. 6 into 12. 72. 72. Which means 100 becomes 72. That's 28, right? 28% reduces. Got it? Actually, this is the effective percentage. We apply the same principle in the compound interest and simple interest. That we will take in the next case.